Morning. Good morning.
Okay, all right. Okay, all right.
Good morning. Good morning, you guys. Good morning, everybody. All right. Well, let's get started. We are now working on day 2 stuff. We should be in day 3, but we are going to finish up with mathematical operations in the rest of today. So let's get started. Grab your coffee. If you're hanging out, then you definitely have some coffee there. And let's just get the day started.
How we could use the plus sign. We saw how we could use the plus sign either to concatenate strings together or as a mathematical operation where we add two integers or two floats, basically two numbers together. In this lesson, I want to show you some of the other mathematical operators that you have access to, in addition to adding. The next obvious one is subtraction, so 7 minus 3, you would just use the minus sign. But then when you get to multiplication, it's a little bit weird. Instead of using the x or some sort of time symbol, you actually use the asterisk. So you would say something like 3 asterisk 2, and that would be 3 times 2. Now the final one is division, and that's done using the forward slash. So 6 divided by 3, and when that prints out, it'll give you 2. Now one thing
I've had to restart this a couple of times just to make sure I'm getting what she's saying. Integer. Hmm. Okay, so based off of what she just said, it should be because she said multiplication and division are on the same line. So it is going to be what is inside of the parentheses first. So it should do the 3 times 3 first. Then once we do, let me clear this out real quick because I think So I think we're going to go 3 times 3 first. Then we're going to do, I guess we could do the 3 divided by 3. Then it will do I really don't know. My guess would be 3 times 3 will be the start. but we'll see. Left to right. Yep. So we were right. We were right. Okay, so in order to get 3, and it goes, I would need a sheet of paper in order to do this. So I am going to use my trusty iPad and write it out that way. Let's see what we get. Because my guess is we're going to go. My guess is gotta draw it first. Okay, so if anybody knows the answer, don't put it inside the comment section. Let's just try to do it together. So I've got, she wants you to get 3. So if it's gonna go 3 times 3, so even if this, okay, so you can still leave that in the same order. The next order is division. Oh, that's easy. So then you would just have to then go take the, wait, so that would be 3 times 3. Then you would go minus, so minus No, sorry. Yeah, that's right. So you would have to, because you would need to. Let me go here. So even if you were to take 3, so change that from, you would have to change that to minus, and then well, if you did, you can change some things. So even if you did, you could do the, oh, I know what you could do. So you could do 3. Hold on. Let me check something real quick. So you would just do 3/3 plus 3/3 would give you, so this would be 1, this would be 1. And then this would be times, and then you would just need this to be 3. So 1, 2, and then you would just need to move this over because this is going to be 2. And I think you just need to do this 3, which will give you, because this, okay, I think I got it. Let me see if my answer is right here. Okay. 6. Yay. We're doing the Bmi calculator now. Okay, and let me get over to the replicator first because I don't think I did that. I didn't. We're gonna fork it over. Okay. So we're going to print. No, because it's a input first. So we're not printing. Hold on, I want to see. Right now, if you hit this, so we need to. I don't know what it is in kilograms. We don't use kilograms. Okay. 2 stones over white. I know it's probably weird, and you're like, what the hell is that about? But okay. Okay. And it is. Okay. Body underscore body minus equals height times oh no, sorry, it's print. Okay, that should give you a syntax error. Oh, it's not that. It's this. That's right. She said that. So 72 meters. I'm gonna go 113. Maybe it is this. I think they're still going to give you a trace back because there is... Why is it? It's printing the height. No. Let me see what she did. So we need to convert them from strings. And here I was entering that as inches. That's the first thing.
line where we're actually doing the calculation. You could do it beforehand. Alternatively, instead of using the exponent operator, because something
we can hear properly. So we're going to dissect this. Let's pull this out real quick. Okay. There is something that I missed. Oh, I did it as a float instead of an integer. She did it as an integer. My question is, why am I not getting the same thing? INT. Technically, I should get the exact same thing that she does. Because I'm not getting a massive number, which I am supposed to. So height in meters. I'm going to put in 1.8 like she did. Kilograms, she put in 66. And then she got a number I did not. So somewhere in here, okay. Those were irritating my ear. So, not in a bad way, just they were just irritating my ears. So,
actually run this code right now, we'll actually get an error. And what it's going to tell us is that on line 8, so right here where our equation is, there's a type error. And it's saying that you're trying to use the exponent or the power function for a string and an integer. So the 2 is the integer, but this is still a string. And we can confirm this if we check the type. So type of height, and let's comment that out, and let's print this. Then
You'll see that when we enter some numbers here, the type of height and weight, in fact, is string, because they came from the input function, which we saw in previous lessons. Before we can actually just simply run the data types, right? Now, the weight is probably okay as an integer or a whole number, because it's already pretty accurate, 80 kilos or 85 kilos. We don't
somewhere in
necessarily
here
need
is where
any
I'm
decimal
making
places.
the mistake
But
and
the
haven't figured
height,
it
on
out
the
yet.
other hand, definitely needs to be a floating point number, because if it was an integer, then there would only be height of 1 meter, 2 meter, 3 meter, 4 meter. And because most people lie between 1 meter and 2 meter, then we really, really need those numbers after the decimal place in order to get an accurate calculation. So the height definitely needs to be a float. And we can convert it into a float using this line of code here, where we're converting this string into a float. And the weight, you can either convert it into an integer or a float, doesn't really matter. So now if we run our code again, you'll see we no longer have any errors, and we're now able to print our BMI. Let me enter my height and weight again, and you can see I'm getting this BMI with a massive list of numbers afterwards. So in our result, we said it should be a whole number. How can we convert this BMI into a whole number? Well, we can turn it into BMI as integer and convert this floating point number, the BMI, with all of its numbers after the decimal place, into an integer, a whole number, which will just simply cut off everything that's after the
Okay, so I have that. And then the next level of code that she did was BMI as an integer equals int BMI. Okay. What the heck, man? This thing keeps floating to the outside, which is weird. My cursor keeps getting lost places for some reason today. As odd as that is. Okay, I don't need you to... Okay, let's see.
The decimal place. And now if we print this BMI as an integer, run our code, then you'll see that we get a whole number being printed out, which is now our BMI. In the next lesson, I'm actually going to show you how we can round these floating point numbers so that when it's 19.5 or above, it becomes 20. When it's 19.4 or 19.3, then it gets rounded down. But for now, this is all that we wanted. We wanted you to be able to cut off the end and turn it into a whole number. If you want to have a play around with the solution code, then head over to this replit over here, and you'll be able to see the solution code with a lot of comments explaining the code line by line and showing you some different ways of...
Okay, so let me look at the replit. All right, welcome back, you guys. Welcome back. So let's see where we are, what we have. We're still trying to figure out where in here, because we have a syntax error, but when she's doing it, she does not have a syntax error. And I was under the impression I wrote everything exactly as she did.
Dependent of their height, right? It's say
This part is just a BMI calculator.
And my weight is
what are we,
63 kilos.
What are we missing?
And when I hit enter, ideally, I would like to get my BMI printed out as a whole number like this. So how can we achieve this? Well, firstly, you have to take a look at the equation that's used to calculate the BMI. It's somebody's weight in kilograms divided by their height squared. Then once you've got the result, we want it to be printed as a whole number or as an integer. So you'll have to think a little bit about type conversion. You'll have to think about the mathematical operations that we learned about in the last lesson and combine everything you've learned so far in order to solve this code challenge. So pause the video now and give that a go.
Okay, so we worked through, we're gonna look and see where we're making a mistake. Because somewhere in here,
all right, so now that
missing
you've had a go at it, I'm going to reveal the solution. In our code, we've already got access to the height and the weight as variables, so we can simply use them straight away. So for example, I could just print the height, and it would be equal to whatever the user typed in when they were asked for it by the input. So in this case, my height would get printed out as 1.8. If we can access the height and weight, then we can calculate the BMI by simply replicating the mathematical equation here. So we know that the BMI is equal to the weight divided by the height squared. So we can take the weight and then we can use the / for divide, and then we can divide it by the height squared. So we're going to use the exponent operator to the power of 2. So this is how we could work out the BMI. But you'll see that if we actually run this code right now, we'll actually get an error. And what it's going to tell us is that on line 8, so right here where our equation is, there's a type error. And it's saying that you're trying to use the exponent or the power function for a string and an integer. So the 2 is the integer, but this is still a string. And we can confirm this if we check the type. So type of height, and let's comment that out, and let's print this. Then you'll see that when we enter some numbers here, the type of height and weight, in fact, is string, because they came from the input function, which we saw in previous lessons. Before we can actually just simply run this equation and get the values we want, we had to convert all the strings into other data types, right? Now, the weight is probably okay as an integer or a whole number because it's already pretty accurate, 80 kilos or 85 kilos. We don't necessarily need any decimal places. But the height, on the other hand, definitely needs to be a floating point number, because if it was an integer, then there would only be height of 1 meter, 2 meter, 3 meter, 4 meter. And because most people lie between 1 meter and 2 meter, then we really need those numbers after the decimal place in order to get an accurate calculation. So the height definitely needs to be a float. And we can convert it into a float using this line of code here, where we're converting this string into a float. And the weight, you can either convert it into an integer or a float, doesn't really matter. So now if we run our code again, you'll see we no longer have any errors, and we're now able to print our BMI. Let me enter my height and
it
weight
wasn't
again.
that I wasn't doing what she put in
BMI
there correctly. I'm going to show you
numbers
where I was
afterwards.
making my mistake, and I
In
just kept
our
looking
result,
at
we
her.
said it should be
Okay,
a whole
here
number.
I had
How can we convert
it
this
like
BMI
this.
into a whole number? Well, we can turn it into
So let me
BMI.
stop it for a second. So the system was telling me, hey, there's like an issue here, and it'll say it's an invalid syntax. And part of that was because you had this space, and in Python doesn't like spaces. So when you go here, it doesn't like this. So when I typed out BMI, now I can run the code just fine. So I think she did 1.6. And then it'll give it to you as a whole number, which is stupidly weird, but that's where the error was coming, was in the way that I wrote it. Interesting. Okay. Let's keep going.
Integer, and convert this floating point number, the BMI, with all of its numbers after the decimal place, into an integer, a whole number, which will just simply cut off everything that's after the decimal place. And now if we print this BMI as an integer, run our code, then you'll see that we get a whole number being printed out, which is now our BMI. In the next lesson, I'm actually going to show you how we can round these floating point numbers so that when it's 19.5 or above, it becomes 20. When it's 19.4,
I just realized you guys
19.3,
can't exactly
down.
see what
But
she's
for now,
putting in
this
here
is all that we want.
because
we
my
wanted
big
you
head is
to
in the
be
way.
able to cut off the end and turn it into a whole number. If you want to have a play around with the solution code, then head over to this replit over here, and you'll be able to see the solution code with a lot of comments explaining the code line by line and showing you some different ways of doing things. For example, instead of converting the weight and height in line, on the line where we're actually doing the calculation, you could do it beforehand. Alternatively, instead of using the exponent operator, because something to the power of 2 is simply just something multiplied by itself, right? Then in this case, you could also just do height as a float times height as a float. Have a play around with this code and make sure that you're comfortable with everything that's here. And if you got anything wrong at all in the code challenge, then go back and fix it. Now in the next lesson, we're going to be talking about more mathematical operators, such as rounding numbers instead of just cutting off the end. So for all of that and more, I'll see you on the next lesson. In the last challenge, where we calculated the BMI, you saw how when we had a number that had a long list of numbers after the decimal point, for example, if I had divided 8 by 3, and I print this out, you'll see that the value is 2.666666. And if we had just turned this 8 divided by 3 into an integer, right now it's a floating point number, but if I convert it into an integer, you'll see that all it does is it just chops off everything after the decimal point, instead of what we would traditionally do, which is to round the number. So if it's 2.5, it would go to 3. If it's 2.4, it would go down to 2. Now in Python, it's super easy to round numbers. All you have to do is to use the round function, like this. If we write round 8 divided by 3, then it's going to round it into a whole number. And you'll see that instead of 2, we actually get 3 now, because 2.6 recurring becomes 3. Now, if you wanted to, you can actually go a step further. You can specify the number of digits of precision you want to round it to. So if I said I want to round it to 2 decimal places, then I could write 8 divided by 3, comma, and then the number of places that I want to round it to. So now our 2.666 recurring becomes 2.67 because I said we should round it to 2 decimal places. So if it makes it easier, it might be easier if I write it like this. So 2.66666, and I'm going to round it to 2 decimal places, and again I get the same result, 2.67. Now another way of modifying numbers is instead of dividing, say 8 divided by 3, we can also use the floor division, so where you have 2 forward slashes instead of just 1. Now we know that whenever we divide any number by any other number, the result always gets turned into a floating point number. Now if you didn't want that and you just wanted an integer, so a whole number chopping off all the numbers after the decimal place, you can just use the floor division like this. And in this case you would get 2 straight away without having to convert it into an integer. And in fact, if I go ahead and check the data type of the result of this calculation, you'll see that it's actually an integer, whereas if I had just used the single / division, then I get a floating point number with decimal places, even if this is a clean division, say 4 divided by 2. This is still going to become a floating point number, and the number is going to be represented like this, 2.0, like so. Now if we had saved the results of this calculation into a variable instead, then one of the things that you can actually do is to continue performing calculations on this variable. So for example, I could do 4 divided by 2, which is going to be equal to 2. But then if I want to divide it by, say, 2 again, I could actually say result divide equals 2.
Well, that's
And
'cause you
when I
gave-
now print results,
That's because you gave results.
I'll actually get
a
1. Because
name,
it's 4
so
divided by
yes,
2,
that makes sense.
then divided by 2 again. Now, very often when you're writing code, say for example if you're keeping track of the user's score, so you could have score equals 0 to begin with, and every single time in your code, say a user scores a point, then you can get hold of this score variable again, and instead of saying score now equals the previous value of score plus 1, you can simply use this shorthand, plus equals. So plus equals 1. And now when we print score, you'll see that it's actually equal to 1. So instead of using plus equals, you can use minus equals, which just takes the previous version of score and removes 1 from it, multiply equals, and divide equals. So this is really handy when you have to manipulate a value based on its previous value, which you'll have to do a lot in programming. Now, the final thing I want to show you is something called f-strings. And this makes it really easy to mix strings and different data types. So far, up to this point, if we wanted to print something like your score is, and then we wanted to print the score, we have to write plus, but of course because these are different data types, this is a string and this is an integer, we get a type error. So we've had to convert this into a string before it will actually successfully print when both the data types match. Now this is quite painful, and understandably a lot of programmers will need some slightly more convenient way of incorporating things that have different data types. Let's say the score is equal to 0, let's say their height is equal to 1.8, and is winning is equal to true. So here we've got a integer, a float, and a boolean, and we want to mix it all in to a sentence that is a string and get it printed out. So instead of having to convert all of these and use a whole bunch of plus signs, and then you have to convert everything into a string, it's really, really painful, right? So what we can do instead is use something in Python known as an f-string. And what an f-string allows us to do is, in front of a string like this one, we type the character f. And it's really important that it goes in front of the double quotes or single quotes if you want to write your strings like this. But I like to use double quotes, and a lot of other Python programmers do too. So essentially you're adding just the character f in front of the string, and now this is an f string, and you can start adding various values into this string. So for example, if I wanted to write your score is equal to this variable score, then I can put that variable inside a set of curly braces like this. And now when I print my string, this one right here, you'll see that it says your score is 0, and it does all of the converting and all of the stuff behind the scenes, and you don't have to worry about any of this. So If I want to continue along, I could say your score is this, your height is, add in the height, and then you are winning is, then let's add that final Boolean value and get it to run.
So
You
the
can see
F
that our
only has
entire
to go
string
in
now
front
prints
of the
out, your
string.
score is 0, your height is 1.8, you are winning is true. So all of these different data types got combined into a string by using an F in front of the string, and then using these curly braces to place our variables into this string. By using F strings, you cut down on a lot of the manual labor of inserting different data types into a string. And this is going to come in really handy just about on the next lesson, where I've got a coding challenge for you. Head over there and complete the challenge.
Of course, every single time you have a coding
So you
challenge.
should see day 2.3, your life in weeks. And this is the challenge that we're going to complete in this lesson. The idea is that there's a really great article by Tim Urban of Wait But Why on visualizing your life in weeks. And I was reading this recently, and it really made an impact on me, especially when you see that a whole life from age 0 to 90 can be mapped out like this in weeks, where every week is represented by a little checkbox. And you can see each of these boxes, right? This is like how many weeks you have in your whole life. And it's not as small as I thought it would be. I thought each of these boxes would be like invisible because they're so tiny, because I have so many weeks in my life. But it's actually not true. There's actually not that many. So in today's coding challenge, what I want you to do is to create a program using the mathematical operations that you've learned about, as well as the F strings that you learned about in the last lesson, to tell us how many days, weeks, and months we actually have left if we were lucky enough to live until 90 years old. The code is going to ask you for your current age. Let's say that I'm 12. And then it's going to calculate the number of days, weeks, and months you have left in your life if you lived until 90. And then it's going to print it out to you like so. And the important premise of this code challenge for all of the tests to pass is that there are 365 days in a year, 52 weeks in a year, and 12 months in a year. I know that because of leap year, it's actually a little bit more than that, but for this exercise sake, let's just call it 365, 52, and 12. Pause the video and see if you can complete this challenge. And then...
Okay, so if you interesting article. Okay. That tells us how many days, weeks, and months we have left. And okay, so okay, this one. What is your, so if you ran this, it would do 43. So now you needed to calculate we were right here.
But you might remember from previous lessons that the input always creates a string data type. In order to do maths, we do still have to do a type conversion. So we have to change our age into a number. So let's call it age as a int. Age is never going to be 4 years old. So we're going to accept this as a whole number. So we'll convert our age into an int. Now the next
Okay, so let's take this out, put it next to what she's writing, and we need to convert our age. So we have to create a variable, which is age as an integer, or just int, equals the input of age. So, okay. And then, no. Okay. And then, how many years remaining equal to 90. Okay. Tracking. Let's keep going.
left. So days remaining is going to be equal to years remaining multiplied by 365, because there are 365 days in a year. And then we can do the same for weeks and months. So now that I've got hold of the number of days remaining, weeks remaining, and months remaining, then I'm ready to actually use it inside my string. But before we do that, it's always helpful to check your code.
So let me go back and finish writing this real quick. So we should cut some lights on in here. It feels so dark in here. There we go. Let's get you on and blam. Okay, so we're gonna get you guys in a different camera too, because we definitely need to switch up. But okay, so we entered days underscore remaining equals to years remaining times the 365 days. Do the so weeks remaining space equals no, years remaining, oh crap, 52 weeks. Okay, and then we have to do months remaining space months underscore remaining. Okay, and 12 should be. Yeah, it should be 12, I think. Yeah. Okay. So it's saying, oh no, because this is wrong. This should be years. Okay, that's fine. We're gonna have you scooch.
Code as you go along to make sure that it works exactly as you expect it to. So let's go ahead and try to print what is the number of months remaining. So if we go ahead and run our code, and let's say that we're 80 years old, right? Which means that we'll have 10 years remaining and we'll have 120 months remaining. So all of that looks pretty good to me. So the next thing we have to do is to somehow output this sentence where it says you have X days, Y weeks, and Z months left. So let's copy that and paste that sentence in here. And then I'm going to turn it into a string by wrapping it inside a set of double quotes.
Okay, so we need to do that step. Let me just put this here so we have enough space. Okay, and I think alright, so let's grab this. Go back over here. We're just gonna drop it. We are going to, I think she, okay, so we're gonna make this into this. Wait, why does this have two? No, you just need, why does that have two? That's weird. You don't need to. Okay.
Quotes. Now that I've got a string, I can turn it into an F string by putting the character F before the string. And instead of having X, Y, and Z, I can replace them with some curly braces inside of which
Got
I
it.
can put.
I know what you got to do. Okay, so you're going to put F right here. And then you're going to put curly braces. And for days, you're just going to put days remaining And here you're gonna put weeks remaining. And then for Z, you're just gonna take the same thing and you're gonna do months remaining. Okay, so let's try to run this. There's got to be another step because we need to create something. I got to that
My
part.
variable names. So I'll change this to days remaining, this to weeks remaining, and this to months remaining. So now that I've got my string, I have two options. I can either just wrap this inside a print statement and print it as it is, but what I think might actually make it easier to read is to save it inside a separate variable called message. And then in the next line, I can simply print my message. It does exactly the same.
Okay, so we then have to give let's say something. Okay, and then you're just gonna hit print. Now let's try to run it. Oh, that's kind of sobering. It says you have 32,850 days, 4,680 weeks, and 1,080 months left. That is super creepy as hell. But okay, I guess. Okay, let's see
Same
what we
thing,
got.
but I think this is a little bit easier to read. So now let's go ahead and run our code and see if we get any errors. It's asking us for our current age. Let's say we're 67 years old. Well, then we only have 8,395 days and 1,196 weeks and 276 months. So I hope you managed to get this code challenge right. And even though the challenge is a little bit dark, well, at least remember that when you become a really good programmer, you'll be able to cut down on a lot of the boring things and repetitive tasks in life. So at least you'll be claiming back some of those days, weeks, and months. So I hope you had fun.
That's something I would love to share. This one, I don't think in Replit we have a way to send these out. This would be kind of cool though, to be able to put this as part of an exercise that I did. Yeah, this one right here was like super dark. But yeah, I definitely want to pin this one. I think that this one right here was super like creepy. But it's definitely something I want to make sure that it is pinned, and that is really cool though. That is super cool to be able to at least look at this code. And I think I'm actually going to put that code, I'm going to save that code. And this is one that I was able to do with her help But at least this part I was able to get done, and I understand what I did. I don't know that we can. That is super cool. Look, I'm gonna keep this code though. I gotta. Now let me go back to this, and I'm just gonna keep this code. Hold on, what does that mean? To a hacker plan. That's interesting. Okay. Well, at least you can take the code itself and you can grab the code. I do need to clean this up because there was some stuff here. That's dope.
Fun with me on this code challenge. In the next lesson, I've got a quiz for you. So head over there and give it a go.
All right, let's go take this quiz. See what we got. You are a computer. What will this line of code print? So this will print it will do the parentheses first. So it will print 2 times 1, which is 2. Then it will do any type of, so it'll do the parentheses first, then it will print, hold on, I know to grab this, and you can put it here. So this is going to print 2 times 1, which is 2, and then it's going to do any type of division. But I'm going to do it in Thani real quick. Alright, and I'm gonna do this in Thani real quick, or drop this in Thani. Alright, and it's going to do the whole entire thing first. Then it's going to do what's in the parentheses. So it's going to do the division first. 6 plus 4 divided by 2 times 6. 4, 2, 2. By 2, and it's going to print 6, 0. Correct answer there. You can just throw it in the Thani and it'll actually show you the steps that it's going through. What is the data type of the result of a variable A in the following line of code? So this is an integer. It's got to be a float because it has the, yeah, it's got to be a float because it has you have this parentheses. If this had just been a 2, then no, it wouldn't have been. Which of these lines of codes will give you an error? Name is equal to input. What is your name? Print. That'll be fine because that'll print the input hello and whatever the person put in here. Name equals input. Okay, print. This won't work right here because this will say hello plus name, and name is not I think it's this one, but age is equal to 12, print. I don't see why this would give a problem. Huh. Now I have 2. I'm gonna go this one. Yeah, because this could work right there once I look back at it a second time.
Hey guys, welcome to the final project of today. And in this final project, we're going to be building a tip calculator. So the final output is going to look like this. It's going to print welcome to the tip calculator, and it's going to ask you for an input for how much the total bill came to. Let's say that we and a couple of friends went out for lunch and it came to $124.56. And then it'll ask you what percentage tip would you like to give. So let's say we want to give a 12% tip. So we enter 12 and hit enter. And then finally it asks how many people are splitting this bill. Let's say there's 7 of us, and then hit enter. Finally it's going to tell us that each person should pay about $19.93. Notice how the final bill, even though after all of these calculations it's probably got more numbers after the decimal point, we only want 2 decimal places of accuracy, so it should be rounded to 2 decimal places. The second thing to remember is that these are percentages, and in order to calculate a percentage of something, you can multiply a number by the percentage number divided by 100. Let me show you this in a little bit more detail. If you head over to replit/appri/tip-calculator-start, then you've got the starting file for this project. And here I just want to quickly show you how the math works, because this project is not about testing your maths, it's about seeing how well you've understood the programming concepts. Let's say that we had a bill of $150. If we were to apply a 12% tip on top of that, then 12% is going to be equal to 12 divided by 100, which is equal to 0.12. Now the next step is we can multiply 150, the total bill, by 0.12, and this will give us what 12% of 150 is, which is 18. Now we of course have to add the tip onto the final bill, so it becomes 150 plus 18. So $150 with 12% tip is equal to $168. Now a shorthand way of doing all of this is simply multiplying 150 by 1.12. So the 1 is 150, and then it's 0.12 on top of that. So when we do this, it gives us pretty much the same number. Now, if during your testing and your coding you come across some sort of number that looks a little bit strange because you think 150 multiplied by 1.12 should actually equal 168 precisely. So what are all of these extra numbers at the end? Now, the short answer is you don't have to worry about it. It's simply related to how Python processes these floating point numbers. If you're really interested and you want to read about this, then I'll link to this page in the Python documentation where they tell you why this is happening. But be warned, it's pretty dense and it's pretty heavy. But the final conclusion is it's just the way that Python is approximating this number, so you don't actually have to worry about this. Now, once we've gotten to 168, the next step is to split it between 5 people. So 168 divided by 5 is equal to 33.6. Now, what we want to show the user is we want to show them the amount that they have to pay.
All right, you guys, we're in the last 30 minutes. Last 30 minutes. So let's continue on.
If this is the case, because that's normally how we represent numbers when it comes to money. So what I want you to do is to also be able to round any of these numbers to 2 decimal places. If you have successfully created this program, then it should work exactly as this example version would, which you can find if you go to tip-calculator-end.appbury.repl.run. And you'll be able to see the formatting where it actually tells you each person should pay this particular dollar amount, and it's rounded to 2 decimal places, and this is the amount after taking into consideration these 3 different inputs from the user. Have a play around with the final product, and then have a think about how you would create this program step by step, and then give it a go by forking this starting repository to your own account, and then try to achieve this result. This is going to test everything that you've learned so far, including f-strings, including complex mathematical operations, including PEMDAS and calculating numbers and the order in which mathematical operations are run by a computer, as well as everything you've learned in the previous lessons and previous days as well. I think this is going to be a lot of fun, and the end result is going to be kind of useful the next time that you need to split the bill between friends. So I'm going to let you pause the video and get on with it, and then once you're done, if you want to, head back over here and I'll walk through the solution with you. But I really recommend you giving it a good go before you come back. So pause the video now and I'll see you later.
Okay, so there is to talk this part out, because there are parts of it that I think that I can do, but I don't know the starting point right now. But I'll try though. I'll try it at least. So let's see. Okay, so I'm just gonna start doing bill equals 150. And then let's try people. I'm just writing down what I think. I don't and let's go. Nope. And we're gonna go tip. Just to draft everything out. Okay. I don't even think you can use percentages. I don't think they allow you to do that, but each person should pay. Okay. So each underscore person equals let's see where she goes with this.
Okay, so we've seen how the program is supposed to work, and we're trying to create it from scratch by reverse engineering it, essentially. The first thing I'm going to do is I'm going to fork the starting project and create my own version of it, which I can edit. Now, the first thing our program should say is welcome to the tip calculator. So that's easy enough. We just have to create a print statement. Perfect. And if you're...
I didn't even... Okay, so this part's fairly easy to do. No, I didn't need to. Okay, so this I can do prints. Okay. I think I missed the space in it. Print is fine. But why is the syntax off? See, why is that syntax? Because there's something in here. Okay, let's keep going.
creating a really enthusiastic tip calculator, you can replace the full stop with an exclamation mark. Okay, so let's run it step by step to make sure that we don't have any errors along the way. So the first step seems to be working. Now the next step is to ask the user for some input, and we want to know what was their total bill, what did it come to. So let's go ahead and create an input and ask them what was the total bill, and then we'll add a $sign or whatever currency it is that you prefer to work with, because when we actually run this, you'll see.
Okay, so inputs. I need to really set that up. I need to make sure I do that too. Before I finish doing anything else, I need to make sure that I do this really quickly. Okay. So that doesn't disturb me now. I needed to get that done. Okay, so what is the total bill? Okay, and she said put your... Got it? Okay.
That the input will go straight after the end of that string, so at the $sign. So now we can enter a dollar amount like this, but it's not really saved anywhere. This data just disappears because we haven't stored it inside a variable. So let's go ahead and do that. Let's call this variable bill, and we'll set it to equal whatever the user typed into this input. Now remember that this bill is going to have a data type of a string, right? So if I go ahead and hit run,
Okay, so we're going to change this to a variable bill equals, okay, how much was the bill? $120. Okay.
And let's just type some numbers in here. You'll see that the data type of the bill is, as we said, a string. In order to be able to do maths, you might remember we have to change this into a number format, so a float or an int. Now in this case, because the bill is likely to have numbers after the decimal place, it's
Float.
probably better that we turn it into a float so that we get the most accurate result possible. Now that we're done with the bill, the next question the tip calculator should ask is, what percentage tip would you like to give? 10, 12, or 15? Or you can of course switch this up depending on how much tip you normally give. So the next line is going to be another input. Here I'm asking the user how much tip would you like to give and giving them some examples.
Okay, so this is how much would you like to give? So here, let's see. How much would you like to give? We're gonna pop that in there. All right, well, actually we've got 2 minutes left. So we are going to pick up on this tomorrow. We're going to leave this right here. We're going to pick up on this tomorrow. I am going to finish out the rest of the things that I need to do, cleaning up some stuff here. But yeah, we've got about just over. All right, you guys, I appreciate you hanging out with me, and I really do. I appreciate you hanging out with me, and I will see you guys tomorrow.